everyone. I'm Paul and I'm here to talk about some shit. Unfortunately didn't factor in the resolution thing, but I think we're going to be okay. Maybe. We'll find out as we get into the talk. I'm Paul Theriault. I work for Mozilla. I work mainly on the Firefox OS project. Has anyone here heard of Firefox OS? Most people? Awesome. Has anyone actually had a play with Firefox OS? Tried downloading it? A few people? Cool. Good stuff. All right. Today I'm going to be talking about mainly around the application security model in Firefox OS and try and do a bit of introduction to some of the tools that you can download yourself and get started with having a poke, writing apps for Firefox OS or web apps in general, because that's the sort of the bigger picture. Hopefully it's interesting. The slides are up on the web at not that address, but I'll fix the address before actually they may even be there still, but that's the old version. This presentation is also actually a web app that you can install onto the Firefox OS that you download, which I'm going to show you how to download. This whole presentation is going to be pretty Inception and meta and stuff, so hold on to your seats. So a bit of an introduction to what Firefox OS is, a bit of information about how you can get started, as I said. I'm going to then dive into the application runtime, because really what we're trying to do with Firefox OS is make the web environment an environment where you can run apps, and by apps I mean like a capital A, like iOS apps or Android apps, making web a native platform, native applications. And then I'll sort of cover threats and controls along the way. Okay, so a bit of a background. So Firefox OS is designed to be or make the web a platform for mobile devices. So the easiest way to think about that is Firefox OS in the original incantation will be basically an Android or an iOS or a competitor to something like that. If you've seen Chromium OS at all, it's somewhat similar in concept in that the basic premise is that you boot into a browser and then you run apps in a browser. It's taken a bit more to a web extreme though. On Chromium you still have GDK providing the widgets and the objects and stuff like that. On Firefox OS, all the apps, and in fact the system app itself, is all written in HTML, JavaScript and CSS, the whole thing. And naturally we've obviously had to change the way, or add things to the web to make it possible to do that. And that's what I'm going to be talking about today. The other big major thing that Firefox OS does is add a whole bunch of new APIs. So like if you want to make a phone call, you just do navigator.telephony.call. Like it's literally that simple to make a phone call. Now obviously that's pretty scary from a security perspective, so I'm also going to talk about how we make it easy to do but then lock it down. So and really this project is a lot about trying to find the balance between making things easy for developers, but also then making it actually secure enough so that we can sell a phone. There's a link there to the homepage. But okay, so diving straight into what Firefox OS is made up of. There's three basic parts. There's Gaia, Gonk, and Gecko. Gaia is everything that you see. So that's the apps, so the dialer, the SMS, the contacts. It's the home screen, it's the lock screen, it's alert boxes, everything. And then that's all written in HTML. Then you have Gecko, and that's a broad term basically just for Firefox. It's literally Firefox underneath it with the UI stripped out of it and a whole bunch of new APIs added into it. And a bit more glue and stuff to actually make it work with the mobile platform. And then at the bottom you have Gonk, which is a sort of a cut down Linux distribution, just enough basically to get Firefox running. And then on top of that, then you can install third-party apps, which like Gaia will all be HTML, Java, and CSS. So that's Gaia as it currently stands. In fact, better, I will actually give you a demonstration. So because it's Firefox, there's nothing stopping you from just compiling it for another platform. Gonk is an operating system that you can compile it for, but you can also just compile it for Mac. So this is Firefox OS running on a Mac. Obviously things like making phone calls don't work, but in terms of, well, it looks like a phone, you can swipe and you can see. So things like the camera app, they're not hooked up to the native APIs or anything, so they don't work. But by intents and purposes for the application platform, it actually works. And that's the main thing I'm going to be showing today, and how you can get started with it, how you can write apps for it, how you can start poking and sort of understand the structure. Yeah. Oops. Thank you for telling me it was full screen. So as I've said before, Gaia is made up of all the apps that come with the phone, including the system app, which is like a lightweight operating system. Then you have Gecko. I think everyone probably knows what Firefox is. But from an application standpoint, it's where you have all your networking stack, graphics, layout engine, all that sort of stuff. Underneath the Gecko layer, and when you first turn the phone on, it's basically a stripped down Linux operating system. It's very similar, actually, if you've ever poked around in the bottoms of Android. It shares some libraries with Android and some common daemons, like there's a real D, there's media server, things that you'll see on Android. But that's about sort of where the commonality ends. And then, as I said before, then there's third-party apps which you install. I'll go into the different types, but basically there's hosted apps, which are more or less just websites, and then there are packaged apps, which are static chunks of code which you get reviewed in a store, and they're much more analogous to your sort of traditional app that you would install from a marketplace. Okay, so since the purpose of this talk is to actually get you started, I'll get you started. When you want to test Firefox OS, there's a few different ways that you can test it. I mean, the first one, because it's essentially, well, most of it's written in HTML, you can just load it in a browser. But obviously most things don't work, especially as we get closer and closer to launch, it gets more and more broken in the browser. So it's good for the individual apps, but in fact, I might just see. Actually, that's not going to work. I was actually going to do some demos, but I tried yesterday and realized that a change in Nightly had broken them. So yeah, it's not so great. There's the emulator on the desktop, which I just showed you. There's also an emulator, which probably works best on Linux. It does work on Mac as well. I don't know, I could probably get it working on Windows, but it'd be a struggle. It's much better in terms of completeness, but it's pretty slow and a little bit painful, and you need to download all of Mozilla Central to get it working. And then when you build it, it actually also downloads pretty much all of the internet, something like, I don't know, it's in the gigs. So it's a bit of a pain to build it. So it's much easier because with Firefox Desktop, you can just download it. And then obviously if you have a device, there's a few phones. If anyone's tried to put it on a phone, you can, a Samsung Galaxy S2 will work-ish, or a Nexus S will also work-ish. But we're not really targeting those at the moment, and given the phones launching next year, there'll be bugs in those platforms. So yeah, well, just come and ask in the B2G channel if you're trying those platforms and you get stuck, and generally someone will help you out. But what I'd recommend is you try B2G Desktop, because it's just so easy to get started. So it's the same as if you're downloading a Firefox Nightly. You just download it and run it. It comes with the Gaia profile installed now, which is very helpful. There's a couple links there to help you get that. Inside the binary, there's two binaries that come with the B2G Desktop. There's B2G itself, that uses the built-in profile. There's also B2G bin. If you want to provide options and set your own profile, you need to use B2G bin. And here's some more tips. I don't need to read this out to you, but one thing, it's a phone, right? So, and it thinks it's a phone. So when you get in here and you're like, shit, Mozilla sucks, it's like a black screen, what the hell? Well, that's because it's a phone that's gone to sleep, so you have to press the home button. Trying to Mac is a function left. It took me ages to work that out. But yeah, so there's lots of things like that, but there's a few tips in there in the slides on how to manipulate it and change the size of it and stuff like that. So that's B2G Desktop. Okay. So I'm now going to introduce a few, key mechanisms that we've introduced into Firefox, or into HTML really, the ultimate goal of Firefox OS is to introduce these new web APIs, not just for Firefox OS, but the goal is to make them standardized and used. So these are two mechanisms that we're proposing to add to iframe to allow you to turn iframes into an application platform, for want of a better word or a better description. But before I talk about exactly what they are, I'm going to talk about the two types of apps that we have in Firefox OS. So you have installed web apps. Installed web apps are literally just a website and a manifest file. If you've ever played with Chrome extensions, they're the same as a Chrome, well, very similar to a Chrome hosted extension. There's one app per origin in the current model, though I'm expecting that in time that might change to allow multiple apps per origin. It's mainly been limited to one app per origin for security reasons for the moment. An interesting thing for web apps, there's no SSL indicator because there's no Chrome. There's no UI that you have like in a normal browser. So there's also no accept assert UI. Basically, it's sort of like STS by default. Well, it's not strictly STS, but if you have assert error, that basically a network connection fails. So if you're designing an app, you need to take that into account. And the privileges that these hosted apps get are quite similar to web content. Because they have the same risk model, they're just content living on some random server somewhere, they have the same threats against them, the server could get popped, whatever, you could get man-in-the-middle. These type of apps don't get direct access to the high-level permissions like making a phone call and stuff directly. And that's why we've created a new type of app, or a type of packaged app. So privileged web apps come in a package, quite similar to an existing Firefox extension. If you've ever written those, it's literally a jar format. The idea here is that you write your app as static HTML, you submit it to a marketplace, and it goes through some kind of review to make sure it's not doing anything stupid or dangerous with the permissions, and then that app ends up on the marketplace. But the key thing about Firefox OS is you don't have to do that. You only have to do that if you want to get the permissions. And the decision that basically what it comes down to is whether you trust a marketplace with giving those permissions. The idea is that there will be lots of different marketplaces, and if you trust a certain marketplace to be reviewing apps or only having trusted apps, then you'll accept apps from those stores. For the initial launch, well, at the moment there's only the one app store, but the intent eventually is to have like anyone can run their own app store, anyone can at the moment can install their own apps, which is exactly what I'm going to show you in just a second. Just before I do that, so the first extension to the iframe that we've got is what's called the mozapp attribute, which basically has as you can see there. So the manifest that I was talking about before, which I can show you. So if you can read that, that's what a manifest looks like. In fact, it doesn't even need most of that stuff, but it basically just has the name, icons, and a bit of information like that. If you wanted permissions, this is where you would ask for it. But basically, you just have that file on in a location where you can link to, and that's how you install an app. Okay. So I'm now going to switch to let's see if that fits. Yes. But it doesn't look like it's loading. Oh. Shitballs. Here's where like the rest of my Prezzo, which I was going to run inside Firefox OS. Let's try getting rid of the screen option. It's going to be really interesting if I have to run it from inside the normal size. Wow. Okay. I don't know why. So that, I swear that worked like 2 seconds before I started my presentation, before I changed my screen resolution. Alright, we'll move into challenge mode. Except that's not using the right profile. Let's just bear with me. So here's a tutorial on how to run the BootGecko desktop on Mac. Hooray! Oh, thank fuck. Alright. Oh, and now it's even working in full screen. Okay. It is a product in development. It is flaky sometimes. But it was going to be a really short talk otherwise. It's not small enough. Why is it not obeying me? Because I'm not using the right command. Oh yeah, the screen has 2 dashes. Don't ask me why. And it's still not working. Shit. Alright. I can do the demos without the... Please give me my profile back. Okay. Alright, we'll just have to make do with that size. Okay, so this is another version of BootGecko Desktop, but I've hacked up the profile for this one. The profile is... oops. You can pull down Gaia just straight from GitHub, and within Gaia you have all these directories, apps. This has all the source for basically all the apps that run on the phone. So when I mentioned before, like the dialer is HTML, the dialer is now called the communications app because it's integrated. That's the dialer. So if you want to go and change how the phone works, you just go in and edit HTML and it will literally change what your phone looks like and how it behaves. Okay, going back to here. So, I have my slides here. It's going to be kind of difficult to navigate, but with any luck. You're sure as hell not going to be able to read them, but that's alright. I really just want it for the demo. Alright, so that was the slide I've got up here. So this is, what I've got here is just a page. There's 2 iframes, you can't really see them, but one of them is a website called dogs.web, which is about how dogs are freaking awesome. And then there's cats kind of lame, and they're on separate domains. They have install buttons. So this is how a website can ask for it to have itself installed. Basically just has to be an event handler. You hit allow, and there now we have the dogs app installed on the phone. And the main point of this demonstration is to show you the segregation that MozApp brings to iframe. So here I'm inside the dogs application, and I'm going to set a cookie which changes the background color. If I then press the home button on my phone and I'll go back into here, you can see that there's actually a timer running inside the frame, and if I can set the cookie here, I've set the cookie to red in this instance of the application. Even though those 2 things are running on the same domain, they're literally loaded from the same web server, they're not considered same domain. That's because of that. Well, it's a combination of MozApp and MozBrowser, which I'll talk about in a minute, but mainly the MozApp, which adds the app to the domain. So the actual domain of the website now includes the app identifier. And that's really important from security, because if you had well, it gets important later on because we allow apps to do cross-origin access to certain things, because that's what native apps can do. Native apps can go and connect out to an RSS feed and pull down data and stuff like that beyond the restrictions of normal web. So if we're going to allow apps to do those sort of things, we have to keep all the apps segregated. I beg your pardon? It's not in the protocol handler, it's in the principal object of, so in Firefox. So basically, there's a extension to the origins when you're running inside an app, and it's basically the origin appended with an app identifier and some other stuff, I think. So you can't really see this, but that web page there has a link from the cat's website to the dog's website. So that's a normal web page. When you navigate to the same one, obviously you see the same cookie. The point is that if I'm, sorry, just bear with me. I meant to install that cat's app before I did that. So because Cats and Sneaky, they try and navigate from their domain. Even so, they're like, well, we're an app now. Maybe I can get to the dog domain. But you can see here it's not red. It's not the other color either. So I can set it to yellow. Go back and look in dogs, and we're still showing that there's complete segregation between the apps. Okay, so that's pretty much Mozapp. The other thing that Mozapp does, which I'll talk about later on, is Mozapp is related to what permissions an app gets. So we obviously need a browser for a mobile platform. Well, we have to write a browser that works inside HTML. So we actually have to write a browser that's in HTML. So we had to consult a very learned scientist on that one, on how to do that. And so we came up with a thing called the Browser API. The Browser API basically, it does a whole lot of nasty things to same origin to allow a parent iframe to look into a child iframe. So that the child iframe thinks that it's actually running inside a browser, and it grants the parent access to do all the sorts of thing a browser does, like so it can view the source of the child page because it needs to be able to show a view source dialog, for example. So it does those sort of things, prevents frame busting and stuff like that. Obviously this is pretty dangerous, right? If you can reach into a cross-domain iframe, then you can pull the data out of it, you do whatever, right? So it requires a browser permission, and currently the only two things that have the browser permission are the browser and the system. And you can ponder on why the system might have that for a minute, I'll get to that. But the point is that, so here we have this is the browser on Firefox OS, and on the right we have the Dogs app again, running inside Firefox OS. So they also have segregation. So even though this isn't running inside an app frame, it's only running inside a Moz browser frame, but it's Moz browser that gives it that segregation.
How will you deal with these frame options?
Next slide. Very good question. So if an app tries to call window.top, or it'll see itself like it would in a normal browser. X-frame options, it appears that it's not framed for the purposes of X-frame options. So it's basically a modified the window object for that. We need to implement browser functionality. Like the entire operating system runs inside one window. So window to open would be really freaking bad, right? We'd no longer be inside the operating system. So basically what happens now when you call window.open inside a Moz browser frame, it doesn't do window.open, it raises an event which then gets bubbled up to the parent, and then the parent handles that. Now, and finally, I'll talk about that in a second, but finally there's also a tag called iframe remote, and this basically creates the child iframe in a separate process, so that partially for performance, but also from a security perspective, so that that process will have reduced permissions. If there is if somehow they manage to even get to a function which they shouldn't be able to get to because they don't have permissions, the request should fail, because when it tries to call back to the parent, it's a little bit complicated, but it's basically a second layer of defense for the permissions mechanism. Now, I mentioned before that both the system app and the browser app have the browser permission. And that's because every app on Firefox OS actually runs inside one of these Moz browser iframes. It's probably not a mind-blowing... I can't say how more mind-blowing this is, so that's why I put the GIF in there, because this is really mind-blowing. Basically what it means is you have this whole nested chain of these Moz browser iframes. In fact, if you wanted to, you could have a browser inside a browser inside a browser inside a browser, but it'd be kind of stupid and pointless, but you could. But the key thing here is that when things happen inside, this is the sort of inter-app communication. Because all the apps are all on segregate domains, this enforces some sort of hierarchy between the communication so you have the system app, which is, can I actually show you that? Maybe. But so the system app is what happens when you first turn on, which then goes and loads the other apps. So it has the most the privileges, and it's the one that if you got code running in that, you could pretty much do anything on the phone. Never mind actually getting native code execution. So if you want to actually see this, it's all well good for me to say this, but I want to show you actually how to poke around and actually see some of this stuff. So the easiest way to do it is actually write your own apps. Apps are just HTML, as I've said. You can just, basically, there's a template inside the guide directory. You just copy that template. It's literally just a manifest file. You change the name of the app. Put in your own HTML, JavaScript, and CSS, and then change the manifest, run make inside the guide directory, and then you just run with your profile. So as I didn't really talk about before, but that's how you run B2G with your own profile. And that's what I'm doing here. That's why I've got my own apps installed here. But you can also just install it as well. So I'm going to install that. Oops. Oh. So here's another interesting thing about web apps. I didn't actually mean to demonstrate this, but apps don't just work in Firefox OS. I just installed Shell, which is a JavaScript shell, and it should, if it works. Hello? Oh, Launchpad's broken. Awesome. So now I have this is a web app that's been installed natively. It's called the Web Apps Runtime. Basically, it launches just a headless version of Firefox that gives you what looks like a native app, but it's really just a HTML page. So this is part of the ongoing, we're trying to make apps, I guess, across platform. You can run it inside a browser, you can run them on an OS that runs on a mobile device, or you can run them on a desktop inside of basically a shim. So that's one thing that's really cool, but actually installing it on what I intended to, it's just going to get really annoying when I have to type. But okay, yes. So now good. So, before I was talking about window.open. So what actually happens when you call window.open? Oops. Let's see. Okay, so here's the dogs page again, and I'm going to try and open it from So I'm inside the shell app here, and I'm going to try and open the dogs app. So what happens is the system app goes, oh, you want to open a window? Fine. Okay, well, I'll open it for you, and I'll overlay it over the top of your application. If we then add what did I do wrong there? Oh. if you want to open it in a new window, saying I really want a new window, what the system actually does is go, oh, okay, and it actually launches a thing called a web activity to launch the browser and open that window in an actual browser. Which I have a nice sexy diagram of just here. So what happened there? So the shell said window.open, that fired a Moz browser open window event, which was caught by the parent window, which in this case is the system app. That then created a web activity, which goes back to the internal Chrome web activity registry. It comes back to system saying, hey, someone's trying to do this web activity. Do you have an app for that? Yes. If there was multiple browsers installed, it would actually pop up to the user and say, which browser do you want to run? And then it opens the browser. So that's showing you how the Moz browser events are handled. But still, you can't really see it, right? So because really you're just doing it and you're seeing the effects. So there's a thing called Marionette. Marionette's a remote debugging tool that works with all Gecko products. So Firefox on Android, Firefox OS. Or so I think it works for Android. I'm not 100% certain about that, but I think it does. What it allows you to do, if the demo gods are being nice, it allows you to connect to a phone and then execute arbitrary JavaScript in different contexts within the phone. So you can actually poke around at these different levels within the application. Where'd my window go? Not that one. Oops. Really? Come back, please. Okay. Alright, I'll just quit that. Okay, so the client for this is written in Python, and it uses if anyone's used Selenium at all, it uses the Selenium JSON something or other protocol, or a very similar implementation. But basically what it allows to do is we import the Marionette library and start a session, which by default should just not work on the one you download because you have to do a change, which I made in my other one. So, I clearly didn't do enough praying to the demo gods. Luckily, this one I actually did prepare earlier. So that script there, basically just first of all we establish a session, we set the context to content, which is within the system app by default. We then we pull out the document.document.element.in.html, so basically the running HTML content of the system app, and then we write it to a file. So this is useful because if you just look at the HTML within the source, you can't really see much because most of the fanciness happens at runtime. So if I go back to my okay. Oops. So this is the live HTML from inside the system frame just opened up in Nightly. So as you can see, it looks pretty weird, right? Because this is how you can see the structure of the actual application. At the top we have the notification bar. So that's what, oops. If I go inside the phone, you can see you have like a drag down notification bar. That's this stuff up the top. We have some kind of packaged app here. Packaged apps don't work on the Nightly platform. the Firefox, you have to actually go into Firefox OS. There's the lock screen there. You have, unfortunately, I wasn't running any normal web apps there. If you had any normal web apps, you could actually just see them because the HTML and stuff would come up from them as well. The reason why the background still works is because it's actually inside a data URL. But anyway, so that's a really handy tool for when you want to find out what's going on inside an application. You can go in, execute JavaScript commands, pull attributes. You can execute those Moz browser events, for example, and see what happens, and see what happens when the browser handles a specific type of Moz browser event. And that's really important from a security perspective, because if you, let's say you wanted to test, okay, what happens as a web page running inside our browser, you can simulate all that sort of stuff with this interface. Okay. All right, so that's Marionette. There's a lot more details in the slides, but I won't talk through them all. But Marionette's a little bit complex to set up, but the details are in the slides if you're interested. Okay, so I'm just going to talk a little bit now about the permissions model. This will be probably most of the end of it. So first of all, there are 4 types of content on Firefox OS. You have web, which is just normal web content. You have installed apps. That's the ones I was talking about before, the hosted ones where you have a manifest and a website. Then you have privileged apps, which are the packaged apps you get from a store. And then you have certified apps. Certified apps is basically Gaia. So everything that comes with your phone is the certified apps, which I've just talked about. There's a slide which explains them. So which apps can get which permissions? So web, as you can see, can't directly get access to many permissions. Basically, anything you can get in the web, you can get in web apps. Installed apps get a few things more, but not much more, because we haven't made any security assertions. We've just installed the app, right? It's just still an app running on a server. It's still a web page running on a server somewhere. So they get access to things that don't really have too much of a security consequence. Then you have privileged apps. So they're the ones that are static and they bear more resemblance to a normal app. It's packaged content. It gets reviewed. They get signed. These are the things that can get access to, like the camera, alarm, and things like that. And then you have certified apps. So at the moment, you can't get direct access to any of these APIs with your apps, but the long-term goal is to try and push these APIs up the stack as we get better and more fine-grained security controls and better tools for, and also I think a more educated user population. Because at the moment, really all we have is like a prompt sort of thing, and people, you can't have too many prompts because people just click yes all the time, and it's just not a really good security model. So what we've tried to do is limit the amount of times that we prompt. We only prompt when the user can actually make a decent decision. You still have to declare permissions in a manifest like you do in Android, but we don't really surface those to the user as part of the UI unless it's something they can make a decision about. So the implicit permissions are things like, the explicit permissions are the ones that have to be prompted. So things like geolocation, camera, contacts, device storage, which is storing pictures or music and stuff like that, and Wi-Fi and things like that. They're the things that actually you go and ask the user for. The rest, it's up to the marketplace to review the app and make sure that the app has the appropriate level of permission. So you basically, when you're installing from a marketplace, you're trusting that that marketplace has done the appropriate level of sanitization. Now I say this, but I mean, ultimately you can just go and have a look at the app yourself. Like, it's just HTML, right? And the manifests are just plain text. So if you want to see what an app's using, anyone can do that. And the store will most likely probably enumerate what permissions an app has. But it's not something that we're forcing upon users, because most users don't want to have to make decisions. Like if you run Android, how many, you go to install an app and it says, Angry Birds wants to make a phone call. Are you okay with this? And you're like, well, do I have a choice? No. So the only choices we're giving them are ones where the app might still be able to work without permission, and the user will be able to understand that permission, the app. So for example, if you need to get the window.navigator.moz telephony API, you have to have the telephony permission inside your manifest, otherwise navigator telephony is null. Here's a really complicated diagram of how the process is kind of supposed to work, and I don't actually want to zoom. I want to just click the link that takes. Oh, it's because yeah. Anyway, it's probably too complicated to go through anyway. But this gives you a bit of an idea. Basically, in hosted apps, don't go through marketplaces, but they're not able to get permissions. Packaged apps go through marketplaces, but they are able to get the more sensitive permissions. But for explicit permissions, whether they're packaged or hosted, the user has the final control over should this app have access to it. And if you go into the actual system itself, you can then change those later. So you can see all the apps and what permissions. So here's a test app that I wrote, and I've given it some permissions. So the point is that when we ask you about a permission, you go yes, and remember this permission. But if later you decide, actually, no, I don't want that app to have camera, you can go back and change it. Okay.
What's this piece of permission?
Sorry, I beg your pardon?
Piece of permission, what's it about?
Hey, TCP socket permission. That's being able to make a raw TCP socket. So web pages can make WebSocket permissions, but you have that handshake that prevents you making normal. But because, if you want to connect RSS reader, or if you want to just, well, the email app actually is the one that uses it, because it has a full SMTP implementation in JavaScript. As I said before, all the apps are completely JavaScript. So if you want to do SMTP, you need a JavaScript. It uses the Node library to do that.
So you don't have like port banning features in this kind of?
Have what, sorry?
Port banning, how do you deal with port banning with intermediate?
Port binding? You can't listen to TCP socket. You can only connect.
Then banning, not binding.
Banning?
Banning, like you cannot connect to a port.
Oh, no. It says you can go nuts. I don't think you can connect locally. I hope you can't connect. There's a bug to say that you can't connect locally.
That's why I asked.
Yes, you shouldn't be able to connect locally. Well, I don't know. We'll see. I have to check on the bug. There's a bug about that, but yeah, because for example, if you're running the debug tools, or there's a few things that listen, so you don't really want web pages. At the moment, most of the trust model with Firefox OS is around the limitation of permissions. So you only really trusted apps get permissions. Eventually, we'll probably want more fine-grained permissions, and then we might expose these permissions to less trusted apps. When we have things like, okay, well, you want a TCP socket, but only to a specific domain, for example. We don't have that granularity yet, but eventually that's a potential. All right. Okay, web activity. So this is the last part of permission. So I've been ranting on about how normal web apps can't get access to all these really awesome permissions, right? Like it's pretty boring if an app can't get access to the camera, it can't get access. So what we've implemented is, it's kind of similar, I guess, to web intents on Android, but this is also intended to be a way of providing mediated access to these APIs. So if you're an app that wants a picture, for example, you just say, I want a picture, and you specify the media type, and then you request that web activity, and then you choose what you want to handle it with. So you can say, well, pick me a photo out of the gallery, or pick me a photo out of the camera. So you would have seen this if you've used Android. It has a similar sort of mechanism. But so the idea is that we have a whole bunch of apps within Gaia that will handle these requests for you. If you want a contact, you can go and ask the contacts app to pick a contact for you, and things like that. Which also means the flip side of that is it means all of these apps and all these handlers are actually security surface that need to be audited. But so if I was someone who wanted to start having a poke around, that's possibly a place you might want to start looking. Just quickly, finally, a lot of people ask me about XSS. So XSS inside a normal web app that's just hosted, it's pretty much the same as XSS on a website, right? If it doesn't have permissions, there's no real difference. But if the app actually has permissions, then that's a pretty big problem, because if it has raw network permissions, or if it has device storage, which gives you access to all users' photos, read and delete or whatever, they could perform actions on the device. So basically, first of all, these permissions are restricted to static apps only. So that's one control. So a hacked server isn't going to result in hacked code on your device unless someone hacks an entire marketplace, but then you're stuffed anyway. What we're worried about really is dynamic content. So like the email app has to display HTML emails, right? Even though the code is static, the content is dynamically generated. So first of all, there was obviously the sanitization, and we audit those sort of routines, but also we have a default CSP policy that applies to all privileged apps. So, and that prevents, well, that only allows JavaScript, object source, and frame source. No, not frame source. Object source, style source, and script source to be self. Who knows, do people know about CSP or don't know what I'm talking about? CSP is content security policy. It's basically a way that you can specify it's usually in a header file, a HTTP header, and you say, I only want to allow certain sources from certain locations. So you can say only load scripts from my own domain, or only loads images from this certain domain. So what we do is we only allow scripts from what's called self, so the same domain, and we don't allow any inline scripts. So even if you were able to inject HTML via XSS, you wouldn't be able to actually do any inject script and then access the permissions. Well, in theory anyway, you'd have to bypass CSP. So it's another defense that you have to get past, basically.
You can also do like data exclusion.
Sure. If you just focused on like data exfiltration, then yes, that's certainly possible. But I guess the bigger risk that we're worried about is really more script injection. But yeah, that's definitely a point though. So if an app is just embedding sensitive, like the email app, if it's just embedding sensitive information, you could potentially exfiltrate. But that's something when we were looking at the HTML sanitizer in the email app, that's something we're very much focusing on. So that's pretty much it. There's a bunch of links in the slide if you want to find out any more information. Yeah. Any questions? Yes.
Firefox depending on.
So, go ahead, Nick. Go ahead. You're halfway through.
All right. So is Firefox depending on any extreme features of underlying frames? Things like directly.
Sure. Yeah, so I haven't really gone into much of that today, partially because it's still being worked on. But I mentioned the remote flag before. So all of the apps, or all the main apps within Gecko or Firefox OS are run in their own content process. So that's to support lowering the rights of those content processes. How far we get in version 1 is I can't say exactly, but the intent is to drop file descriptors. There's a guy working on putting a seccomp sandbox around those content processes, so that we have a completely sandboxed. But yeah, as I say, will it land in version 1? I don't know. The other thing is the target device for Firefox OS this is supposed to be a smartphone for like the developing world. We're aiming for low-cost hardware, so that the power of these is much lower. So running heaps and heaps of processes becomes a bit of an issue. So we'll probably see apps being combined in like low-risk apps, probably all combined maybe in one processor or something like that. So the exact process model depends on system requirements very much. So yeah.
So are there any plans for providing a compatibility layer encrypted in JavaScript to run iOS or Android apps?
To run iOS or Android apps? I haven't heard any, but I guess you could potentially do that. I'm not aware of any. But one, for example, there's a project within Mozilla called Shumway, which is running Flash inside JavaScript. It's a Flash run. It's a shockwave runtime for JavaScript. So so there's definitely, and this, I don't know if anyone's seen PDF.js. It's a PDF engine written entirely in JavaScript, and that's actually what's used in Gecko to render PDFs.
how are you going to handle auto updates, say when there are bugs in Firefox and everything? Who's going to be pushing this out? Is it you or them?
Very good question. We had the security review that last week. Actually, by the way, if anyone doesn't know how Mozilla works, all our security reviews and stuff are completely actually public. If you want to dial in and jump on this stuff, you're more than welcome to. To answer your question, the mechanism will be very similar to a combination of Android and how Firefox currently does it. The Gecko update is literally the Firefox update. You download a MAR file, which is kind of similar to a zip file. It's signed, that sort of thing. In terms of frequency and how we push, it's more or less up to the carrier. But at the moment, we're working with the first carrier, so I don't know in terms of, is that what you meant, frequency? Or
well, frequency and who controls?
Who controls
when you give it?
I have no idea. I'm not high enough to make those sort of decisions, so I don't really know. But yeah. Any other questions? Nope. Okay. Thanks very much.